So this session will be solving some problems together where problems are based on certain given condition. Sometimes in a biquadratic equation they are telling that solve the equation if sum of two roots equal to sum of other two. Sometimes it will be given that roots are in AP, solve the equation. Sometimes it will be given that two roots are related by the relation in such a way that their sum is equal to 0. So let us start solving those kind of sums. Let us start with this problem where it is given that you have to solve this biquadratic equation where product of two of its roots is 1. So you just take four roots as alpha, beta, gamma, delta. Then alpha plus beta plus gamma plus delta is minus 2, you know. Alpha beta plus alpha gamma, alpha delta, beta gamma, beta delta, gamma delta equal to 5. Take this one, number 1, number 2, and product of the roots taken 3 at a time. This will be equal to minus 4. And also alpha beta gamma delta equal to 3. Okay. Now the condition given that product of two of its roots is 1. So let us assume that alpha into beta equal to 1. Immediately we get product of the other two roots gamma delta equal to 3. You can take product of any two roots. This is not necessary that you have to take alpha, beta, gamma, delta this order. You take alpha, gamma, beta, delta then, or alpha, delta, then beta, gamma, doesn't matter. So once you get alpha into beta equal to 1 and gamma into delta equal to 3, you take this condition as number 5. And then from 3 what you get? By using that condition alpha beta 1 into gamma, 1 into delta, gamma into delta is 3 alpha plus 3 beta is minus 4. So gamma plus delta plus 3 into it's alright. But from 1 we haven't used it so far. From 1 what do you get? You get gamma plus delta equal to you can apply it here. Put gamma plus delta equal to minus 2 equal to minus 4. So two into alpha plus beta equal to minus 2. So alpha plus beta minus 1. Now you already have a condition alpha beta equal to 1. Alpha plus beta equal to minus 1. So if you take this one as number 6 from 5 and 6, you can say that alpha beta are the roots of x square minus sum of the roots plus product equal to 0. So solution going to be x equal to minus 1 plus minus. I hope you all recognize this. This is going to be x equal to omega and omega square. Okay. Similarly, when you are using this condition that gamma delta 3, you got gamma into delta 3, and here from 1 by putting alpha plus beta minus 1, we have gamma plus delta equal to minus 1. Therefore, gamma delta are the roots of the quadratic equation x square plus x plus 3 equal to 0, and x going to be so these are 4 roots of the given biquadratic equation x4 2x cube 5x square plus 4x plus 3 equal to 0. This question we can refer as a skill-based problem. If you know the theory, directly you apply and solve it. No specific concept is there. It depends on the solving skill from a student side. Just get the roots of the equation. Okay? In this problem, roots are given to be in AP. So you start this manner, you assume that roots be alpha minus 3 beta, 4 roots, 4 terms in AP. You normally take this manner. So sum of the roots and sum from this consideration is 4 alpha, because minus 3 beta plus 3 beta minus beta get cancelled. So alpha is 1 by 4. We can write all 4 conditions, but let me try with different manner. I have taken some of the roots. I will be just using one more condition, product, because you have taken the advantage of only 2 unknowns, alpha and beta. Product of these 4 roots so this will be and this product is going to be product of 4 roots minus plus minus plus, it is 10 by 4 only. Okay. So now by putting alpha equal to 1 by 4, we have to solve this equation. Product 10 by 4, 5 by 2, whatever. Put alpha 1 by 4 over there. Ten by 4, therefore 1 minus 144 beta square cross multiply 10 by 4 with so 1 minus 144 beta square is equal to 640. Don't solve, think. If the problem arises this manner, what to do? Should I go for exact solution? You definitely can go. But we just check once that this is also in the form of 16 beta square. So you take 16 beta square equal to y. So this is just for understanding. 9y okay, quadratic, and 640 is product of this thing. Let us make this observation that 8 into 80. If we have taken that y equal to 9, then what do you get? This is minus 80 and this is minus 8. So let us do it from there. Therefore, we take y equal to 9. 16 beta square 9. So alpha going to be fixed. But beta you got, alpha is 1 by 4, beta you got plus minus 3 by 4, okay. So you got alpha 1 by 4 and beta 3 by 4, or alpha 1 by 4. So what are the roots here? Roots are alpha minus 3 beta, alpha minus beta, alpha plus 3 beta, alpha plus beta, and the next one is alpha plus 3 beta, isn't it? So what are the roots you are going to get there? Minus 2, minus 1, 1, and this one just check once. Well, it is coming to be. Actually, I did a mistake here. This is minus of 1 and 5 by 2. 10 by 4, 5 by 2. So this is minus 2, minus 2 by 4, minus half. This is 1 and this is 5 by 2. The common difference remaining 3 by 2. This is okay. If you start with this, you will be getting all these roots only, but in reverse order. Okay? That alpha plus 3 beta will be in place of alpha minus 3 beta, alpha plus beta, and alpha minus beta, they exchange their place. So I am not going to do this much. Idea you have. For this one, it is given that roots are in GP. So if roots are in GP, you take roots in this form, alpha by beta, alpha and alpha into beta. So beta going to be the common ratio. Now, sum, sum equal to alpha by beta, and this is 26 by 3. Don't write sum of the products taken two at a time. Directly write product. Product is alpha by beta, alpha, and this alpha cube is equal to 8. So alpha is 2. Therefore, so alpha by 2 plus 3 alpha, 26 by 3. Check once. Oh, sorry. We got alpha equal to 2. So not beta equal to 2. Isn't it? So we'll be putting that only. Alpha 2 is just substitute there. Extremely sorry. So this is 2 by beta. 2 beta 26 by 3. So beta is the LCM. Therefore, equal to 20 by 3 beta. This implies that 3 beta square plus 3 equal to 10 beta. So 3 beta square minus 10 beta plus 3 0, milliton break. 9 beta minus beta plus 3 0. This is 3 beta minus 1. So you got alpha's value fixed too, but beta going to be, again, one is the reciprocal of the other. So roots are going to be what? Roots are alpha by beta. You take beta equal to 3, alpha by beta. 2 by 3 alpha, alpha into beta. And these roots will be getting in opposite order when you take alpha 2, beta 1/3. I am not going to do that. Okay. Let us practice a sum of this kind, where they have asked you to find the value of sigma alpha square beta square. Last session I promised you that we will be solving few sums of this form also. And those, if suddenly they ask question like find the sum of 99th power of the roots of the given equation, that is huge, but that, or 10th power at least, that will go with the help of Newton's formula. I hope next session I will be able to show you some problems based on Newton's formula. Let us do it now. Here, alpha, beta, gamma are the roots of this equation. So sum is minus p. Alpha, beta, beta, gamma taken two at a time. Alpha, beta, gamma, no. Gamma alpha is q. And alpha plus beta, alpha, beta, gamma equal to minus r. For the first part, that alpha square, beta square, this is what? Summation will go on these three numbers, three symbols only. So this will be it's okay. This you write alpha beta, beta gamma, gamma alpha whole square minus 2 this into this into, so 2 alpha beta gamma common, and you put their values, that alpha plus beta plus gamma. Hope you have understood. a square b square plus a square plus b square plus c square is a plus b plus c whole square minus 2ab bc and c. You just put the values here, that sum of the product again 2 at a time is q minus 2 into minus r and minus p. So you got sigma alpha square beta square. Next part is what? Sigma alpha 4 runs on 3 symbols, so it will be alpha 4, beta 4, gamma 4. This is nothing but alpha square, beta square, gamma square whole square minus 2 into alpha square, beta square, gamma square, alpha square. Okay? Now, this thing you can write alpha plus beta plus gamma whole square is square 2 into alpha beta, beta gamma, gamma alpha whole square. Again I am using a plus b plus c whole square minus 2ab. Actually this thing we have got earlier, no? So we will be using the result over there direct. But if you haven't got earlier, so you need to do the calculation. Put this here, p square minus 2q whole square minus 2 into q square 2r into minus p. Okay? So this is going to be p square minus 2q whole square minus 2 into, not simplifying it, simple. Hope you have understood. This session I have arranged just to make you habituated with the symbols and application of sigma sign. Hope none of you are confused so far. Now for here, alpha, beta, gamma are the roots given of this cubic equation. So alpha plus beta plus gamma is minus q. Alpha beta, no, it is 0 because no x square is there. 0. Alpha beta, beta gamma, gamma alpha is q and alpha beta gamma minus r. So to get the first one, symmetric function of roots, you write this as alpha square by beta gamma. If you take beta square here, it will be gamma alpha. Gamma square here, it will be alpha beta. Okay? Now take the LCM. And this is going to be alpha cube, beta cube, gamma cube. You write this as alpha cube, beta cube, gamma cube minus 3 alpha, beta, gamma and add also. This divided by alpha, beta, gamma. Why have I done so? Because you know factorization of this thing. Alpha plus beta plus gamma, alpha square, beta square, gamma square, you know it, plus, and that divided by alpha, beta, gamma. Now this thing, alpha plus beta plus gamma, you see, this is equal to 0. Just put it there. 0 plus by alpha, beta, gamma. So first part, sigma alpha square by beta gamma, you got equal to 3. Clear? Now for next one, can you tackle this one? Alpha plus beta plus gamma 0 given because no x square is there. So this is huge, no? If you don't use something from the beginning. Let me do it here. We're going to do part 2. You just simplify it, 2 beta gamma minus alpha square by. Now alpha plus beta plus gamma equal to 0, you know. So you write this as 2 beta gamma minus alpha square. Beta plus gamma is minus alpha. So this is going to be alpha square 2 beta gamma by 2 alpha. Isn't it? So we can simplify it now. How to? You can just write this as alpha by 2 minus beta gamma by alpha. By using the given condition, we got this. So how can we write sigma this thing now? This is going to be equal to sigma alpha by 2 beta gamma by alpha. So this is nothing but sigma on this and sigma on this. This is alpha plus beta plus gamma by 2 and this is alpha beta gamma no. This you have to take care because it is sigma beta gamma by alpha. So you write beta gamma by alpha plus gamma alpha by beta plus beta alpha by gamma. Okay? Alpha plus beta plus gamma is, we have seen that this is 0 and here you take, so this is going to be beta square gamma square alpha square, and this thing we've done in 3/4 sums. This is alpha beta gamma alpha whole square minus 2 alpha beta gamma that divided by alpha beta gamma. Okay? And what have you got? Sum of the roots taken 2 at a time. This you got q. So you put q over there and this part 0. So this is minus q square by product, and this is 0 because alpha plus beta plus gamma is there, it is 0, and alpha beta gamma is minus r. So simple. So value is q square by r. Okay. This time I have taken just to remind you that how to find sigma alpha 1 square alpha 2. Thing is complicated because here if you find the sum of all these things and try to factorize, it will not work. Sigma alpha 1 square alpha 2 means many terms are there. N C2 number of terms are there. This combination not possible. So we will be using a technique I might have discussed with you earlier. For this one, we start with the result of this product, sigma alpha 1 into sigma alpha 1 alpha 2. Okay? Let us start with this product. It is going to be alpha 1 alpha 2, alpha n. This is alpha 1, alpha 2, alpha 1, alpha 3, and so on. We are not here to write all the terms. Something we have to understand without writing. Now, when you multiply this and this will give you alpha 1 square alpha 2. Isn't it? And multiply this with this, you will be getting alpha 2 square alpha 1. So all those terms of the form alpha 1 square alpha 2 coming. In addition, you'll find alpha 1, alpha 2, alpha 3, alpha 2, alpha 1, alpha 3. I mean, things are going to be repeated. But how many? If you multiply this with this, you will get alpha 1, alpha 2, you will get alpha 1 square alpha 2. Multiply this with the next term, alpha 2, alpha 3, you will get 1. Alpha 2 with this, you will get another 1. Alpha 3 here with this, you will get another 1. Another 1 means that alpha 1, alpha 2, alpha 3, those terms are coming thrice. So sigma alpha 1 square alpha 2 you are getting here, and first three symbols alpha 1, alpha 2, alpha 3, they are coming thrice. Sigma alpha 1, alpha 2, alpha 3. So you have started with this alpha 1 into, you know the value of this, you know the value of this, you can get the value of this thing. Therefore, it is going to be sigma alpha 1, 3 sigma alpha 1, alpha 2, alpha 3. What is sigma alpha 1 for this sum? I did not write here, but you know, it is minus P1, sigma alpha 1 into alpha 2, P2, and alpha 1, alpha 2, alpha 3 is minus P3. Just substitute there. Substitute. Sigma alpha 1 is minus P1, P2. So this is going to be 3P3 minus P1, P2. Understood? The second example, similar type I have taken, just to make you understand, just to count how many terms of product of 3 or 4 will be there. So like previous one, what to start with? To find sigma alpha 1 square alpha 2 alpha 3, we start with, we start with this product sigma alpha 1 into, this is alpha 3, alpha 1, alpha 2, alpha 3. This is actually alpha 1, alpha 2, so on. And this is going to be alpha 1, alpha 2, alpha 3, all these combinations. Alpha 1, alpha 2, alpha 4, all. Alpha 1, alpha 3, alpha 4 plus this one. Cannot write all. But once you do this expansion, you can see that this side, when alpha 1 multiplied with, let us write this another term, plus alpha 2, you have to imagine, alpha 1 multiplied with this will give you product of 4 terms. Alpha 1 multiplied with this will give you sigma alpha 1 square alpha 2 alpha 3. Here sigma alpha 1 square, alpha 1 square alpha 2 alpha 4. Here alpha 1 square alpha 3 alpha 4. This manner it will be sigma alpha 1 square. And question, how many terms of product of terms taken 4 at a time and the sum to be considered. Alpha 1 with this will give you 1. Alpha 2 with this will give you another alpha 1, alpha 2, alpha 3, alpha 4. And alpha 4 with this will give you alpha 1, alpha 2, alpha 3, alpha 4. And alpha 3 with this will give you another alpha 1, alpha 2, alpha 3, alpha 4. Beyond it, alpha 5 starts. So we will be getting 4 sigma alpha 1, alpha 2. It's alright. Therefore, sigma alpha 1 square alpha 2 alpha 3 is sigma alpha 1 minus 4 sigma alpha 1, you know, it is what? Minus P1. And taken 3 at a time, it will be minus P3. 4 at a time, it will be 4P4. So, P1, P3 minus 4P4. Clear? Now, suppose in one sum, they have asked you to find the value of, it is not given here, but I am telling you, it is sigma alpha 1 square alpha 2. How to find this sum? It is alpha 1 square by alpha 2 plus alpha 2 square by alpha 1 plus alpha 3 square by, all these are coming. So for this sum, our approach will be similar. What is that? We start with what? Sigma alpha 1 into sigma alpha 1 by alpha 2. You will put the values, definitely will simplify and then write the result. See you in the next session where I hope I will be able to discuss both Newton's formula or technique to find the sum of higher powers of the roots and transformation of equation. After that session, we will be starting solving ISI CMI problems. It takes long time, you should have patience. Thank you.